Okay. So I hope everybody's doing okay today. And this day's been a long time coming. We've been talking about it for a very long time. The IAs are officially due today. So I've already started grading those that have been turned in. And I think they're looking great so far. Um, I'm going to go ahead and do these a little different than I did the rough drafts, because the rough drafts, I was providing feedback, maybe some guidance here and there, kind of, asking questions. But on the final IA, it's more I'm making notes for myself, like what I'm observing as it applies to the rubric and things like that. So you'll probably see little things like that when I pass those back to you, but it won't be until after spring break. But like I said, I'm taking tomorrow to go ahead and finish grading the rest of them and kind of see how the rest of it turns out. Anybody have any questions on it? Okay. Well, let's see. We've been talking about the law of sines, which, as we can see here, sine of angle A over side A equals sine of angle B over side B, which is sine of angle C over side C. Or you could flip that. But really, if you're going to solve a triangle, an oblique triangle, one that does not have a right angle, find all the side measures, all the angle measures, all that good stuff, you have to have a what in order to use the law of sines. Well, now that's a type you could be given. You could be given two sides and an angle, but I'm referring to what combination of items do you have to have in order to use the formula? Gabby? There you go. You have to have an angle measure and the side directly across from it. Okay. So like here I was given angle 40 degrees and side directly across. I refer to those as a pair. So the only way you can use law of sines is you have to have a pair in order to create your proportion. Now if you don't have a pair, that's where the law of cosines is going to come in. But it looks like we're not going to be able to talk about that until after spring break. So I know everybody's pretty sad. Oh, speaking of, completely forgot, how did the test go yesterday? For those of you who took it. You didn't cry, so that's a good sign. Okay. Do we feel pretty good about the math sections? I know I'm not supposed to ask anything specific, but I'm just kind of curious how you guys felt you did.
Yeah, the math section wasn't actually that bad.
Yeah? Okay.
There was one.
What do you think was harder, the no calculator or calculator?
The no calculator was harder.
No calculator was harder? Really?
Yeah,
Okay.
there was one about radians, and I didn't know what radians were, so I took guess.
So at the front it said how many radians were in a circle, and so like you just have to look at that.
Wait,
Do you want me to actually explain to you real quick what a radian is?
so I asked my brother about it, so he told me what it was.
Oh, okay.
Yeah.
Okay, cool.
Apparently it was 180 degrees.
It was like 2 pi and then at the front.
It was
Yeah, because one revolution in a circle is 2 pi radians.
Yeah, I was like, what is a pi radian? I was like, I guess not.
Hey, there you go. Hey, guessing is a great strategy on a test like that.
I guess.
Okay. Well, let's see. I don't even remember when we did this. I want to say it was last week because we tested Monday. Tuesday, I don't think we were able to do a whole lot. I think we talked more about the ambiguous case. Is that right? Okay, and then I didn't see you yesterday. Huh? That's what we did. We took most of the time to talk about the test. That's right. Okay. But I remember we got through the majority of the ambiguous cases. Now, this was what? If you had what kind of case?
If you had a side-side angle.
Side-side angle?
Yeah.
Okay.
And you could have like two different types of triangles.
Okay. There we go. And it's one of the things we talked about. Really, more than anything in here, we really talked about consistency, starting with a triangle that looks like this, then creating an obtuse one, and just kind of running with the information, assuming that there's always going to be two triangles, and then if one doesn't exist, you're going to come across something that's going to let you know that for sure. And I believe we got through 2 of the 3, is that right? So I think we only have 1 left. So this is the only one we have left, right? Okay. So let's go ahead and see how far we can get. So A is equal to 11, B is equal to 5, and angle A is equal to 105 degrees. Now, just for the sake of consistency, the diagrams that I'm about to draw are not going to be correct by any means. Remember, I always say start with an acute triangle and then go for the obtuse one. Okay. Now, it's been several days, so I always recommend the angle measure that you're given, put that in the bottom left corner. So we're going to go ahead and make this corner A. So this is 105 degrees. And the side across from it would be 11. And then go ahead and make the other side the upper portion of your diagram. So if I'm going to put the 5 here, that means this is B, and that's got to be C. And then the idea was that this side that's 11 units long is going to swing back and forth like a pendulum. When he swings over, he's going to be able to connect at the base again and form a different triangle. Okay. So like I said, again, we're just going with consistency. If this were pre-calculus, I'd be going through that chart that I showed you previously. Did anybody actually want a copy of that? I don't remember. Okay, if you do, just let me know. So this would be A, but I can't go ahead and label the other ones as B and C because they're not the same angle measure. What did we do the other day? Yeah, B prime and C prime. Okay, B prime and C prime right there. Okay, so here's all the information. Let me go ahead and fill this in again. So this would be 105 degrees. Let's see, this one would be 5 as well. And let's just see if triangles like this could exist. Okay, so I do have a pair in the first triangle, and for the ambiguous case, you're always going to be provided a pair. Whatever angle you're given, you're always going to have the side opposite that. So I'm going to start by saying sine of 105 degrees over 11 equals, okay, well, the only thing I can find now is angle B because I've got the side across from it. So I'm going to say sine of B over 5. Yeah, I can do it better. Whoop, that's weird. I can do it better. 5. Okay. And then, of course, you cross multiply. Sine of B would equal what ratio? What would be in the numerator? Okay, so 5 times the sine of 105, and then we divide that by 11. Now, here's the thing. You remember, we're not going into a whole lot of detail with this as far as our trig goes, but you evaluate a trig function at an angle measure, and it gives you the ratio of the sides of a triangle. Okay, well, what do I do if I'm going to work backwards using the ratio and I want to find the angle measure? We've got to take the inverse. There we go. So I'm going to say sine inverse of that ratio, 5 times sine of 105 degrees over 11. Okay, so let's see what we got here. I do not have that pulled up, so if you'll give me just a few seconds to catch up with you guys. There we go, 3rd time's the charm. Okay, so let's get to calculate. All right, so trig sine inverse. Interesting. Let me escape out of that. Control divide. Okay. So control divide. So up top we had 5 sine of 105. And we're going to divide that by 11. Okay. All right, so when I push enter, it's giving me 26.04. Okay, so we can go ahead and say 26 degrees. Okay. All right, which is about 26 degrees. Okay. So I'm going to say this is 26 degrees. And things are looking good for this triangle so far. Now that I have 2 of the angles, I can go ahead and easily find the 3rd. So what's the sum of all 3 angles? 180. So I'm going to go ahead and take 180 minus the 105 that we started with, minus the 26 that we just found. So I'm getting 49 for the previous one, or sure for the last one. Okay. And now all I have to do is go ahead and figure out that last side, the base. Okay. So again, I would probably go ahead and recommend sticking with the same pair you started with. I mean, you could do this, but I'd encourage you to use the decimal that you find in your calculator. So I'm just going to go ahead and say sine of 105 over the 11 equals sine of 49 over little c. Okay. Is that okay so far? Then we cross multiply. So c would equal what? Okay, so 11 sine of 49. Divide that by sine of 105. Okay. So let's see what we got here. We don't have to take the inverse. We're not looking for an angle. And I totally forgot those values. 11 sine of 49. So 11. Okay, sine. Okay, 49 over sine. We did it again. Of 105. Okay, so what should I get when I push enter? Okay, so about 8.5. So let's say 8.6. Okay, is that what everybody's getting? Okay. Now let's turn our attention to this guy over here. So remember, this side, CB, he swings over so that this triangle, okay, is actually contained in the other one right here. All right, that's where we're going to go ahead and form that other one. But this also works to our advantage because in this triangle right here on the right side, let's go ahead and call this D right here where it connects, or in this, I'll just keep it consistent. That was B prime. Okay, that is a isosceles triangle, right? So what do we know about the angles of an isosceles triangle? There you go. So if I were to extend this guy over here, again, just to help you visualize it, we found that to be 26. That means that should be 26. So let's see. Oops. Let's see what the other one should be. So we already have the 105, but let's see if that works out. I got 180 minus the 26. I got 154, but does anybody notice a problem? Yeah, those two angles, their sum is greater than 180, which means we're not going to be able to get an angle for that one. So that other triangle doesn't exist. But the previous triangle, yes, I was able to get one out of it. Okay. All right. Questions? Now, I actually put something together based on a question that Eli asked the other day. Let's see, I have a triangle right here, because I think that's the end of the notes, correct? Okay, so let's say we have a triangle, okay, and it had to do with an inverse sine. So let's say I have A, B, and C. Okay. And let's say angle A measures 25 degrees, B is 50 degrees, and then we have 105 degrees here for C. Okay. And these are going to be rounded. Let's say that AB is 38.84, we got 17, and we got 30.8. Okay. So let's say we have a triangle with all this information. Well, I want to go ahead and just kind of emphasize something that Eli talked about, because he said on one triangle he used sine inverse, but it didn't give him the correct measure. Does anybody remember what it is I'm referring to? What was it we were talking about? Okay. Well, let's say we don't know what this measure is right here. I mean, obviously we know it's 105, but let's say we wanted to use the law of sines to go ahead and find that. Okay, so let's take a pair. Let's say 25 and 17. So I'm going to say sine of 25 degrees over 17 is equal to, now let's say we don't know what that is, so I'm going to go ahead and say sine of C over the 38.84. Would everybody agree? Okay, so with everything we know so far, I mean, should be coming up as 105 degrees. So sine of C is going to equal, cross multiply. So I'm going to have 38.84 times the sine, okay, times the sine of 25 degrees. Change that sign, okay, over the 17. Okay. Oh, 1738. It actually happened. I knew it was going to happen. See, if you believe in something hard enough, it will happen. There we go. Okay, anyways. Now we have to take the sine inverse, right? Okay, so let me take the sine inverse of this real fast. I'm sorry, I got excited about that. I didn't even realize. That's cool. Document B. Oops. Okay, get rid of that. Okay, so sine inverse. Let's see. Well, this isn't English, but it's going to be lit. And I've forgotten the numbers again. Okay, 38.84. Okay, so 38.84 times the sine of 25 over 17. Now remember, I already provided you that it was a 105 degree angle. So when I push enter, 74.9, so I'm getting 75. Remember, what was it that we brought up the other day? What's wrong here? Do 105 and 75 have anything in common? What?
They're complementary angles, right?
They're complementary angles?
Are they supplementary?
Supplementary. There we go. That's exactly right. Okay. Now remember, supplementary means that I can add the two angles. The 105 plus 75 is going to give me the 180, right? So C came out to 75 degrees. This is something that you're going to have to be really careful with when it comes to the law of cosines, and why I recommend, if you have to use the law of cosines to start a problem, I would recommend you continue to use it so that you never have this problem. The issue is when you take the sine inverse, okay, sine inverse is only ever capable of giving you an acute angle. In fact, that angle is always going to be supplementary to whatever the angle should be in this case. Okay. Now, you can use it. I mean, if you know for sure that the angle you're looking for has to be obtuse, I would probably go with the law of cosines. But in a problem like this, let's say these two were missing and you knew this one had to be acute. If the angle you're looking for is acute, sine inverse will work. Okay, but not if the angle you're looking for is obtuse. So the good news is when you're solving triangles, how many of those will there ever be? Only one. Okay, only one. There's either an obtuse and two acute, or they're all three acute. It's got to be one of those two cases. All right. So Eli, does it?
Yeah, that makes sense.
Does everybody remember what we were talking about the other day?
The law of cosines, just like, well, the law of cosines work in every single case we get.
Oh yeah. Now see, here again, it depends on the items that you're given.
Well,
Because for the law of cosines, there are certain situations you either need all three sides. Like that's typically the main case while we go ahead and use it. So like let's say we have a triangle, and I'm just making one up right now. Let's say this is 9, 11, and 12, and I want to know what the angle measures are. Okay, well I can't use the law of sines because I would have to have at least one angle in order to help me out, right?
but you can use the law of cosines.
I can use the law of cosines. Or if I had two sides and the angle in between them, the included angle, law of cosines works really well. And a lot of times you'll be able to use what you know from geometry to go ahead and figure out if an angle is going to be obtuse or not. So let's just say this is triangle ABC. So I have no idea if this is an obtuse triangle or not, but which one angle, if it was, would have to be obtuse? Would it have to be A, B, or C? Why B? What's wrong with B? There you go, because it's across from the longest side, so B would have to be the largest angle. So it's little clues like that. So could I use sine inverse on, say, A and C?
Yeah.
Absolutely, and you would get the answer you want. But until we know whether that is definitely obtuse or acute, probably not a bad idea to use law of cosines.
Also, if like let's say we knew B was obtuse,
Mhm.
we still use a law of sines.
Now that's a good point. If you know for sure it's obtuse, you could use the law of sines and take the sine inverse. You would just have to remember to get its supplement, not the angle that you got from the calculation. And of course, yeah, if you had A and C, then you could have B. Okay. So there are different ways, but it's really easy to forget. In fact, that was a big problem in a lot of my pre-cal IS classes when we were going over the same material. Okay. All right. Unless anybody has any questions, that's all I have. No? Okay. Now, here's what I'm going to go ahead and do. I'm going to let you guys decide. I have the homework for this, but I am not assigning anything over the break. Okay, I'm not assigning any homework over the break. So what we can do, if I were to give you the homework today, you can bring it in tomorrow. You have the entire period as well to go ahead and work on it. Probably even get it finished before you leave for the break. Go ahead and turn it into the tray. Or I could just leave it with the substitute tomorrow. You just have the one period. What would you guys like, Gabby? Let's do it today. Sounds like a plan to me. I like it when students say, please give me homework. Okay. All right. So for those other people who aren't here today, should they show up tomorrow, I'm going to leave the stack with the substitutes. Okay, here we go. All right, so this is not going to be due the Monday we get back, the 18th. Again, take your spring break. I'm sure you've got other things you want to do besides math. I can't imagine what that could be, but, Hmm? There you go. Okay. So we'll probably have it due probably that Tuesday or Wednesday just to give you a little extra time so you don't have to do it over the break. Okay. But there you go. All right.